Hello, folks. I think we're going to do some stuff on vectorization today. Flip this over. That would be a good thing to have done. Welcome. Let me think. Where last we left our hero. So we had this thing, if I recall correctly, we had this weird bug where double buffered training didn't work. So I think I'm just going to bite the bullet today and welcome, Pepe. I think I'm just going to bite the bullet today and I'm going to work on some more dedicated tests for this. That'll be good. Right, so this is what we had before. This is just a performance test. So I think what we want... We probably need to make like a test environment. Well, we can start with breakout though, can't we? Yeah, I think we can totally start with breakout here. And then I think that the only goal I will have today... Oh, actually, I have to check one thing to make sure I don't have important emails. Cool. I have email I was expecting, but I don't have to do anything immediately, so we can work on this for today. So I think that the plan here, yeah, we should actually totally just go to just do this. So let's see what is required from this. Ocean squared.h. We can pretty much just take all of this stuff, and then I think we can minimize it, right? Yeah, this is what we're gonna do. We're just gonna hard code in. So this will be a test environment. It doesn't need any of these real metrics at all. We'll just do absolutely minimal template here. I believe we're using float actions right now. and float obs. Yeah, so we can totally just do this. And then int tick is fine, right? Tick int val. Do this. Yeah. So I'm just gonna basically make a super dummy env, and we're gonna start using this for correctness checks, and then we'll use it for perf checks afterwards. Because basically we'll make an env that has 0 overhead, and we can use this to test max throughput and whatnot. That'll be good. I don't know why I'm so tired. My gosh, I thought I was well rested. I went for my my morning run, like decent but not super hard pace. Got all my exercise in yesterday. It's just the getting close to the holidays. I kind of think I'm just implicitly expecting a break. Alright, so where are allocations for this? Oh, we need to define. I see. So this can do nothing, right? And then this can do this. What do you do with day off? About 50 sets yesterday. I can barely move my my arms. Super sore. Got some good training in. It's so far so good, man. And some of the things that I thought were limitations, George Hotz actually replied, and it turns out that you can actually do a lot of the things I wanted to do. It's just not documented. So the plan is that I'm going to work on this right now, and we're going to do more stuff with Tinygrad, because it's actually still pretty promising. I init. Does this need anything? I think so. Yeah, this is just empty, right? Where's the env struct? Oh. Admittedly, that was very easy, right? This is just super dummy env. Now we need build vec to do test env. Test env. Yeah. That sounds good. And then this one is fine. Redefinition. Is it like this? Env is breakout. Hey, Ratswag. Welcome. What did I do here? Struct. Oh, it's annoying. Use of undeclared identifier. What? How did I break false? Yeah, how did I break false? Wait, standard bool. Am I dumb? I didn't think you needed... I thought that was built in. Oh. Okay, so... We shall do this now. You'll get test env so. You will. So this is the exact same thing as breakout in sizes, but it's not doing any work. Ah, look at this. We have 45 mil SPS. Cool. This number is going to have to go higher, I think. Though actually, hang on. That's pretty good, isn't it? Because if you do 45 mil, 118 is the ob size times 4. Yeah, that's 20 gigs. That is 21 gigs per second of memory transfer. And I think the max is 32. Like, the max possible is 32. So actually now, we are above 50% efficiency for the first time in the history of RL. Get rid of this bot. What were things Geo told were possible after the fact? The main one is variable size shapes and kernels. So if we can just get this thing to generate as kernels that have variable sizes, that helps me a lot. That really helps me a lot. push N back to being bottleneck? No. Actually, because the thing is, vectorization is gonna cut cut a lot of the env overhead. So we're optimizing everything, man. Honestly, there's very little uncertainty left in the new update. Like, I pretty much know everything we need to do. It's just, like, a lot of work, and I'm kind of tired, so the goal is to kind of carve out a couple chunks of this before I have to take at least several days off, over the holidays, and recharge, and then come back and do more stuff. Like, realistically, I should have just taken a week off, like, probably 2 weeks ago by now. But I've kind of wanted to keep getting some stuff done. So I've just, like, kind of taken a night off here, a night off there, kind of a thing. I mean, I just want to have things capped off so I can actually rest when I decide to. Probably next week sometime, I'll take some time off. Let me see how we initialize this. See, the thing that's difficult is I don't think you can get access. So this is a vec-env type, right? And vec-env has m star m's. Is this fully defined? Let me actually check. Printf. Pointer to incomplete type. Yeah. So this is what we need to figure out. So it's not going to be defined in the header. Can I get the type information? You can't get the type information from the DLL, though, is the thing, because that's not comp time. This is the downside of doing this via DLLs. I'm probably going to come up with something eventually not requiring this, though. I don't know. There are nice sides to this as well. Incomplete type. Well, we can still get access to observations, right? Nope, not going to NeurIPS. No big conferences for a while. Latest fitness article on X if you'd like to know the reasoning behind that. There are a bunch of people at NeurIPS I'd like to talk to this year, but I'll stay here. This one works, doesn't it? Ob size. Wait. No, you don't even get this, do you? Or... Nah, that's lame as fuck, dude. Not my style. Just not my style. Okay. So... now we have the ability to do some form of benchmarking at the very least, right? Is there a way... I don't think if there's an easy way to number these. I think there is. What first got you into RL? I mean, it was really around the era of the Atari results. I started RL like when pretty much all the new stuff was coming out, and then it was a combination of that and then like seeing MMOs as this new target, and kind of like seeing RL as a fundamentally different approach to intelligence, and one that like works really, really well with games. And like, you know, using games to advance intelligence in a really interpretable and natural way. This. Okay, that is everything here. Really like to number these N's. You know? Wait, I totally can. You dummy. You total dummy. First DeepMind results. No, I haven't watched Thinking Game. Originally, it was Atari, yeah, and Go. Atari and Go, and then the thing that was like that really, really got me excited was Dota. I still think Dota's the best result the field's ever gotten. It's kind of becoming one of those nuclear fusion things, right? Where like we have not had a better result since 2019. That's definitely going to be one of the goals I have with Puffer, is to get a better result than Dota. I'm trying to think what would qualify. A full MMO would definitely qualify. It's tough because in my mind, like, even a really useful result is not necessarily the more technically impressive one. They never really training costs for Dota. I mean, you can estimate it, right? It was 1,000 GPUs for a couple months, and then the big one was 100,000, 50 or 100,000 CPU cores. That was for the final training run, and they were using more than that for development, presumably. It's not a lot of money by today's standards in AI, though. The thing, it was a lot of money for back then. Just the quality of techniques or quality of training data. I'll just let the Dota AI guys play with and simulate in the same amount of Dota teams. Yeah, that's what they did. The thing is, it's like Dota is such an impressive problem to solve, and for all of the right reasons. Yeah, it wouldn't cost as much now. It would still be expensive, but the thing is, like, the majority of the training costs for that thing are because the game is expensive to simulate, right? Like, you can totally implement Dota to be 100 times faster than it is. Like, games are never optimized anywhere near the extent that is possible. Okay, I'm trying to think what I want to do with this. I don't want to just be waffling around here. So I can do 2 of these, can't I? Do like this: 2 buffers, 4 threads, 16 environments, size of 32, like this. This will be vec 1. Okay. So now do there's the guy Autark who said that he got it was kind of funny. He said that he got like super fast Game Boy emulator, but then he was profiling it wrong. So we'll see if he comes back and actually gets something fast. But yeah, pretty much any emulator that you would get. I don't even think you can do an emulator, to be fair. I think you'd have to like nativize stuff. But anything that would get you access to a large number of games at least 100,000 steps per second. Ideally, you'd want it to be more than that, though. Yeah, that would unlock a lot. The problem is it's very difficult to think of anything where you could get access to a bunch of games that run at that level of perf. Like, you're pretty much limited to very old games, stuff like Game Boy games, and then like the problem is writing an emulator that is that fast is hard. So I don't know actually what else you would do. Um I don't know if it's possible to like nativize those things automatically. But yeah, like that type of stuff is really awesome. And the thing is the perf targets can just get higher and higher and higher. GBA games built in C natively. I mean, they're built for the thing is they are built for the hardware, right? It's developed for cartridge, man. Kind of a miracle. Like the thing is those games were something of a miracle if you think about it. Like how hard developing for cartridges. I mean, you have games that are like still fun to play. Like 3 decades. 3 decades? Yeah, literally 3 decades later. 19. Yeah, 3 decades later. And they were like just perfect on release, no ability to patch or anything. Pufferlib ports. If somebody has done it fast, like it has to be by somebody who actually understands the perf targets of RL, right? Like it's so much higher than you would do normally, and it's not unrealistic at all. Like you can totally make games run that fast. They actually aren't doing that much logic. You have to be thinking of it. We have to put we have to copy yeah, it's pretty sketchy. I mean, I guess we can just start with this. Moderately annoying test to write. Okay. Segfault. Cool. Very cool. I don't know what the segfaulting is about, but we'll get to that. So let's now go check our test env. Then we'll just get rid of val. Observations. This. Okay, perfect. Now we actually have a viable test, right? Let's go to 0 threads. Okay, we still get an error, right? I still get an error. Hmm. For your base? No, seasonally. I move around seasonally. I'm in Maryland at the moment. Welcome to the Puffer training facility. I do spend some time in the summer, in California though. Doing float for Vec 2. Are you not doing float for Vec 2? You're reusing the pointer, right? I mean, this is expected to be wrong because our training is wrong at the moment, so. Now let's see if this does anything first. You think? This one is also, well, that's actually, no, that's expected. Hang on. Hey, welcome. I'm trying to think how I want to do this. Pass 0 fails on 1, right? Ah, wait. Extend. This is 1. Gotta be 1. There we go. Got it. So according to this, we pass the CPU sync test. Ah, look at this. So it's failing with threading on. That's interesting, right? But I was testing it with no threading. I was testing with no threading, and this actually passes. I mean, I wouldn't say I'm exactly fresh, but let's see if I can spot anything now. I have stepped away from it for a bit. I got stuck on this bug on Saturday. Threads. Great. Okay, so we called create environments like this, 8192Ms, right? 0 threads. So numEnvs, 0 threads. Last year, master student working on medical AI. Regression. You don't use RL for regression. You use RL for interaction tasks. So it really depends on your problem. RL is not the solution to everything. It's just the current solution to many things that I'm thinking about that's being like very much overlooked elsewhere. Typically for RL, you want a problem that requires a lot of interaction and a problem for which you can have a very fast simulator. Those are good candidates for RL. Mess something up with the block sizes. Doubt it, but we can just try. Hang on. Try this. Thanks, Happy Coding. Thank you. Yeah, so it doesn't look like this works. This is about the result we were getting before from the broken version. That's non-trivial learning, but it's not good either. Not block size. That's weird. I mean, this is telling me that I have these identical. And then... Except with this... But I have 0 threads, so, like, we should start with that. I mean, is it possible that after all I just do have some dumb thing broken in compiled eval? See how I would mess that up. Buffers. Hmm. I really don't see anything wrong with this, man. The single-threaded one is completely synchronous, right? We do have float observations, right? Vec size divided by vec buffers. Yeah, this is the entire thing. And vec receive doesn't do anything with The single-threaded version. I mean, this literally the entire code. Device to host. Get your actions, right? Spec actions. Start. We try to render it again? We could try vec render on this. Let's try this DLL test thing again. We're gonna try. Yeah, this is what we're gonna do this time different. This. Like this. Then we also need the we need this to be breakout. That doesn't do anything. That's weird. Why does that not do anything? If I do 0 threads. Ah, it does render. Oop. Is there a way I can set actions? There should be a way I can set these actions, no? Go to device synchronize. Oh. I don't have access to CUDA functions in here. The shared library. But I do. I can do it here as a test, right? That seems odd. Paddle doesn't move. That seems odd to me. Oh. Hang on, this needs to be breakout. Still no? Well, that's interesting. This does get compiled. Hello, welcome. That is very interesting, right? We can go look at that. You finish creating. You end up requesting that username. Yeah, I don't know why they denied it, actually. Thank you for reminding me. Go look. If I can find the thing. I guess I can request it again. J-S-U-A-R-E. Okay, I'm not doing this on stream. I already did this stupid thing. Good job, X. I already did that. But I will go do that again off stream. It's super annoying. Oh yeah, I ordered one of these and it has not showed up yet. I ordered one of these more than a month ago. Like, where's my phone? Minimal mean they're shipping it by carrier pigeon? I think even a carrier pigeon would have been here by now. Might have to be 2 carrier pigeons carrying it together on a string. And so actions is not getting populated. Okay, wait, we have some other options here to debug. I'm kind of just being slow today. Okay, that's very curious. That's very weird. Back actions. Am I doing this wrong? What? Here we go looking up the docs of memset. See if I've gone insane. Ah. You dummy, because I forgot that it's not. Okay, let's do it this way. Still no? Oh, no, we're good. Now it's moving. Mem copy. That's kind of obvious. Okay. Floats. GPU action to start, value. Try this. Let's see. We're just trying to make sure that actions are getting processed and shit. Okay, this is good. So, I'm not going insane. Actions are getting processed here, we see. You set actions in here, they do get propagated. Oh, hang on, unless I'm being dumb. No, we're still good. Let me see. And I can just set this to like 1, for instance. And it'll just do all one action, right? Okay, so actions are being correctly propagated. Huh. I'm trying to think what other sources of error we could even have, or what test I can even write. Because I have the other test passing. I'm gonna go look at pufferlib.cpp again. I can figure this out today, damn it. This code works with one buffer, but not with two. Let's actually go double check that I didn't break that real quick. Yeah, so we can see immediately way better, right? If we have two buffers. And I would suspect that the error then is in here, right? I did want to, so yep, this is expected. Is expected. Okay, so we have I. Not used anywhere else, right? H buff. Buffer times horizon. I'm trying to think what type of error could possibly get caused by having two buffers here instead of one. State. Why? Cool. Said answer one thing. What the heck could this possibly be screwing up? It's either here or it's in the env, right? And I've tested the env. I think the env is fine. I have it exactly the same way. I don't see how you could be breaking the indexing here, though, either. Oh, yeah, I opened Discord because Jess had something, didn't... Check. Fuck. That's funny. Where's Jess's thing? Oh, it was Tim, actually. Oh, like threads, calic buffers. I didn't think so, right? They're calic to num agents, right? Which in this case is num ems. Yeah, so it's calic to num ems. Float, float, float. Yeah, that's fine. Num agents. Correct. Trying to look for a specific algo. Global potential field optimizer, so it's non-local. We can ignore local minima. The fuck? No, you don't have global optimization algorithms. Those do not exist. I don't know what you mean by potential field, though. Spec receive doesn't take H. Huh? What do you mean? Did I miss something? No, it would take the buffer index. H is the current time step. Buff is the index of the buffer, so you alternate back and forth between buffers. I also, for context, right, I wrote this test to make sure I was not screwing anything up, and this passes, this thing here. So I made it with 0 threads with 1 buffer and with 2 buffers, which is what I'm doing here. I reset both of them. I set them, the obs, I initialized the obs the same. And then the step actually just increments all the obs by 1. And then this passes, right? So this one gets received every other because it's buffered. This one gets received all at once. You go through the current block and you check they're all equal. This is stepping the... yeah, this is stepping the buffered one, or the sync one, and then this is the buffered one. So this passes, which leads me to believe I'm not doing anything completely stupid here. Though, I mean, this is admittedly a fairly brittle test. Oops. Like, what else would I be screwing up, though? This is not true. Just LM bullshit. I guess I can check these. Okay, so there you go. Size of actions. This is correct. Right? 32K. Because it's times 8. Expected. I can do CUDA check on these, right? Totally fine. This is CUDA Malik. They're CUDA Calic. Hang on. CUDA Calic. CUDA. Go try something with this. Because I guess technically it could be something weird with that. Doesn't look like it though. Yeah, see, this one just gets stuck at like 20s. There's no single point of failure. Well, it's weird because I have a test that basically says that this matches the single thread, the single buffer version. But somehow it doesn't train, so I don't know what to do about that. Layers, batch size, hidden size, right? I swear if this ends up being some C++ bullshit, I'm gonna be so mad. Attempt. Yeah, I'm just baffled by this. I'm trying to think what else I can do. I guess we have to do this. We have to just invest more in this test. Pain in the ass, but I don't know what else to do. Two M's. Threads, two buffers. Basically just do this. Okay, so this is now with breakout. Ooh. That's interesting. What has gone wrong here? Well, hang on. Now they share RNG. Damn it. Yeah, they're gonna share RNG. That's annoying. Well, I had it like this in the first place. Yeah, see? This is the only random. What if we do this? Ooh, okay. Okay, I like this. You take, there was just one little bit of randomness in there. Yeah, so now we have obs matching. Okay, so I mean, now we have a complete test that says that with these settings, which are exactly what we're using, at every single step, these buffers are the same. That's what we have. I guess we're not inputting any actions, though. That's a good way to do that. There's one other thing I want to try. There? No, not really, actually. I had it right. Yeah. Anybody have any ideas? I'm all ears right now. So what the hell's going on? Like, what haven't I checked? You said this transfer is good. Right. Okay. It's literally the same thing. Literally the same thing. And I have a test. It's gotta be something in Pufferlib then, like the C++ here, right? I don't know what the hell it would be, but should Val be commented out? I leave something in? Yeah. These are just testing things. Wasn't sure if it was still being called. Shouldn't be. Same as before here. Oh. This is just such a bizarre bug to me. Like, I'd understand if I had bugs in threading, sure, and I would be able to do stuff, but like, when there's no room for there to even be anything wrong, what the fuck do I do? Like, what the heck? Is something just getting silently copied and just fucking with me? Is that it? Like, I can't think of anything else other than Torch just being a piece of shit and like silently making a copy here somewhere. But like stuff is getting copied in, otherwise it would be 0 reward. Or not 0. Episode it would be like 8, I think. 8, 7 or 8 is the highest you get randomly. Above that, end with the buff. Fuck. I'm trying to think like what other test I can even write. I've literally written this code for the stepping of the end, right, with breakout. And it works flawlessly. It's like every byte is the same. This is alternating exactly as you'd expect. Go look torch select. Returns a view. Okay. Narrow. Return tensor and input share the same underlying storage. Zero. Zero. Pufferlib env action. I literally synchronized the device though. And there's no custom streams. The whole thing is super simple. Like there's gonna drive me nuts. It was like how, right? I'm trying to think what else I can even what else can I do to figure this out? They all get stepped exactly in order. Get stepped twice. Yeah, it works perfectly. Works perfectly. What's the bug? I'm running this with 0 threads. So literally it's just running this block. And for whatever reason, this works with 1 buffer and it doesn't work with 2 buffers. Like, the thing doesn't learn. And I literally have a test that it's the exact same everything with 1 buffer or 2 buffers as well. It's weird. Driving me nuts as well. Nuts. Infinite. Back in it or something. Perfect. Gonna do this before I forget. There's nothing in train, right? Depends on this. There really should not be, right? Oh. No, nothing in here either. Yeah, there's gonna be some good stuff from Tiny. I'm probably gonna do that stuff tomorrow. I just really want to fix this bug today, and this is driving me nuts. Just like so incredibly painful to figure this out. Like, I don't even know what test I could write that would be better either. I guess it's worth doing this with actions. It shouldn't change anything, though. Really should not change anything. And the thing that drives me nuts about this is supposed to be the easy one. Like, there's the threading shit to fix after this. Like, why is this hard? This is supposed to be fucking trivial. So why is this driving me nuts? I mean, I'm so limited as well in what I can even do to debug, because the whole C++ harness is horse shit. Ob's batch. You know what else I can do? Let me test. There is something I can do. Yeah, there's something I can do to test. Okay, hear me out on this one. We're gonna create the environments. We're gonna keep one buffer. Okay. I thought of something. Let's keep one buffer here. But I'm gonna do if So you're going to receive here. And then we're going to do over here. That makes sense? I think that makes sense. This should isolate whether it's in the C++ or in the env code. Definitively. This will actually be good. I'm glad I thought of that. Yeah, good luck with that. Okay. How the fuck is that gonna segfold instantly? Does not make any sense, right? I see. It's gotta be received 0. Hang on. Hang on. Let me get this. This will be a good test. Okay. This still works, you see? This still works. Next, what we can do... And actually that works, that full solve. So we know it's actually fully correct as well. So that's... Okay, perfect. Good. I can work with this. I thought of some good tests. Okay, so we're gonna do both vec receives here. And we're gonna do both vec sends here. And we're gonna see if that changes it, okay? Buffer. Dang. Growth on this has been nuts. Go check one thing. Cool. Go. Come on. Okay, so this doesn't work, right? This does not solve everything like before. So, this indexing code is right. Somehow, use of 2 buffers is bad. We make 1 stream per buffer. But we're not going to use these anyways. Threads is 0. Num_ems doesn't change. Creating 8192Ms, right? Okay. So far, so good. Vec reset. Vec size gets set to num_ems, right? Yes. Hello, Jess. What's Vec reset do? Calc to the size of the threads. Oh, that's 0. Wait, that's 0. This should be buffers. That seriously gonna... This buffers? That would change anything because we use this. No, see, this is still broken. Okay, but let's just kind of careful here. This one's fine actually because there's nothing in there. No, still no. Thing though. Okay, so now you're gonna go to vec buffers. Hang on. Vec buffers is buffers, right? Okay, 2 buffers get reset. All right. I need a few minutes, and then we will continue. I need a few minutes. This is driving me nuts. Don't let me forget to unmute my mic. And I forgot to unmute the mic. Hang on, Liberty. I'll respond to that in a minute. Let me go, is this hot? Could be hotter, 1 minute. Okay, so you typically you don't want to render the game at all if you can avoid it, because rendering is slow. And well, at least on the scale of things that we'd like to run, rendering is slow. And even if you do render it, now you have image observations, which typically require a little stack of convs to process, which is also slow. You don't ever need it at a huge resolution. One of the nice things about rendering is you kind of eliminate the problem of having a really complicated observation space, but you pay a lot for that. Like, you're gonna pay probably a factor of 100 in perf. Like, tens of thousands of steps per second is typically max we see. And then with threading, I've seen like up to 150k maybe. But it's still not great, and it doesn't like... It's really not what you'd like, ideally. Now, if you have something where you actually make that faster, and you can get up to a couple 100,000 steps per second per GPU without consuming all the cores on a multi-GPU machine, that's another story. But we kind of just have not invested in doing that yet, and that's quite hard to do in general. I think ob spaces... The thing is that, like, ob spaces become pretty tough. I'd kind of rather solve the ob space problem anyways, because the action space problem is still there, right? Like, you still have to design your environment for a reasonable action space, even if you render. So it doesn't just solve all your problems, and it's a bunch of engineering. There's like no fundamental difference from like training from pixels being better or more general either. That's kind of just like an academic stupid thing. How did OpenAI do it? They did not train on pixels. They had state access, and they could run tons and tons of instances of the game. So yeah. The reason that the Game Boy emulator is relevant is because, like, older games had really shit hardware, right? So the idea is that if you run a old game on modern hardware, maybe it's actually going to be pretty fast. But then the thing is, like, the older games weren't designed for PCs, at least not a lot of them. They were designed for like handheld consoles. So you have to run them through an emulator, and then making the emulator fast is tricky as well. So yeah, there's a whole bunch of stuff, frankly. Whole bunch of stuff. Funny. Huh. Alright, let's fix this freaking bug. Let's go. We got some more info at the least. Oh. Oh, come on. Am I that stupid? Dude. The fuck is wrong with me, man? What is wrong with me? Apologies for the delay on the vectorization backend, folks. I am a fucking moron, as it turns out. Well, this is one of those bugs where, like, how happy I would be at fixing this is balanced out by how fucking stupid I feel for missing this for so long. I'm actually even surprised the LLMs missed that one. That one is super obvious. That's just me being a fucking goober. God damn. Amateur hour in here. This is why you don't write code when you're tired. Like, it just takes longer to debug it than it did if, like, I just wrote it fresh. Honestly. Yeah, I was just indexing some random-ass starting address in observations. I had the completely wrong address. I guess having like multi-dimensional, having like nice syntax for multi-dimensional arrays, dynamically allocated would be really nice in C. There's a way to do it, it's just really obnoxious. Yeah. Well, at least we finished this with at least a couple more hours to do some real work. Yes, that was literally it. That was the thing that I spent like 5 hours looking for. I almost never do that, where I spend 5 hours looking for something that stupidly simple. I don't even know, man. I need a vacation. What is your longest training time? Like a week on 6 GPUs. But that's kind of a dumb way to measure scale, right? Because it's like, if you look at the amount of data we process or the number of steps we train or stuff like that, like, we've made Puffer so fast that a one machine training run can actually do a lot of work, right? So, I mean, another way of saying that is that we trained on 12,000 years worth of gameplay, and we've done that 3 or 4 times at this point. Stupid bug. That's such a stupid bug. Well, now we can go, we can go look at other stuff, I think. At least this did make us, this did make us write a decent test, which we will now benefit from. I'm gonna comment out this randomness here. Yeah, I'm gonna comment this randomness. Is that gonna mess us up? No, this should be fine. Oh, let me reply. I have one client message to look at. All right. Are the demos on the Puffer website results from fully trained models? Yes, with some small limitations. We discovered a bug in the deployment code that can screw up the policies to some extent or another. So some of these are pretty much exactly as they're trained. Some of these could be substantially worse. But yeah, you do have all the demo models on the site. These are running live in your browser as well. These are not videos. Like, here, I can hold shift. Where is it? Yeah, now I'm playing, right? And then from any point, I can just let go, and the agent will take over. It's pretty fun. Oh yeah, for folks watching, what are you doing? Star the Puffer. If you have not started the Puffer, help me out. It's free. It's absolutely free. We don't like it when the curve goes concave. We like convex. We like convex optimized Puffer. Gotta keep feeding the Puffer so he gets bigger. We have a fair few folks on Twitch today. I don't know what happened with discoverability. Usually I have everybody on YouTube. I probably should, like, figure out how to do the Twitch branding and stuff correctly. But because I launched the stream from Restream, like, there's no way to set a category from there. A little annoying. Okay. Next thing, we're gonna run this test. Okay. Alright, cool. What is this? This all passes with the rebuild. And now we do reds. And we see if it passes with the reds. Oh. Is it just hanging? Interesting. Oh, no, it's not interesting. You dummy. Commented a line and then you forgot about it. Yeah, we can totally get a version of this to work today. That'd be nice. Let me make sure I get this correct, though. You want one stream per buffer, not one stream per thread, right? Atomic Store. Okay, this is fine. So this is the one that we wanted, right? Atomic Store. This Atomic Store, right here, needs to be set up. Boom. Okay, cool. Now we have an actual genuine failure to look at, presumably. It's interesting, though, that it passes the first 200. Let me go double check this thing for errors again. Ah. What happened to puffer boxes? Date CUDA. Okay. What did we allocate here? This is now correct. You create these threads plus 1, right? You make 1 extra thread. Good. And then what do we do in vec reset? Vec reset synchronous still, because we're lazy. We got vec send. Okay, so you have this async copy. We store this buffer. This is send. And on receive, there's receive. Right, and we probably have the same stupid bug up here, don't we? The thread manager. Hey, look at this, same stupid bug. Look at that. See how I did it? Wait, how? You dummy. This need to be here too, doesn't it? Start times ob size. Actions don't get copied there, that's fine. And then where is this? Rewards terminals. What about actions? Where actions get copied? It's in send, right? Did I do this correctly? Yes, I did. Boom. Loads. Thing. Does this work for 0 threads? Does work for 0 threads. 2 buffers as well. Oh, and we see that it actually got way farther that time, which is interesting. So it's very random. We can try synchronous copies. Alright, we can just try synchronous copies. This. We can see if it's a bug in that. That should be good. What are we doing here? Indents. Okay, we are still failing. We have no asyncs in this entire file. Yep. Still fail. Okay. That's interesting. On 30. Wait, I'd like to get the index. Good evening. Hello, Tim. We fixed the no thread. We fixed the 0 thread, or like the main thread based version of this. It was a really stupid bug. Now I'm fixing the much more complicated version of this. I thought it was, oh, and. Eh? What am I doing? No. Head is fuzzy when I'm doing shit like this. Come on. There we are. Activations, exit 1. This. Index 2. This should be J. 4096. Perfect. Look. You see? This is what I wanted. Interesting. Not always on 4096. Ugh. Let's like unfuck this syntax here. So this is threaded, but all the transfers are synchronous. Right? So if actions are ready on the CPU, broadcast to wake up, add end index to block size. Here, block size plus. So this is you've completed a block, right? Where's threading start index get updated? Right here. And there's only one of these threads. So this should be safe, right? So what do we get? We get work index, completed index, end index. Something like that. Yeah, work done. So start index is just a regular variable. This gets random block size. Start. Now we have to make sure we did this correctly. Start is done buff. What the heck is this? Oh. Let me see. Now we'll have to make sure that's correct. All right. I just have some messages I'd answer. The main thing I can think of is messing up the indexing of like job completion in here, right? As you add the block size in, whoops. This is always in increments of block size. You only ever increment the completed index when it's actually completed. Index is less than index. Wouldn't you just do this while completed index is less than hang on, what if I do completed index? Still mismatches. Ding. Okay, so what do I do? What do I do? Well, this check is better. Frankly, a lot of stuff. Oh yeah, we were gonna check the done buffer thing, right? Done buffer times block size. Already on CPU. What do we do? Vec receive. Not atomic load. Ops ready on CPU, and then we synchronize. Fine. That's totally fine. Just keeps ticking, right? Okay, other than that, let's see. Reset is fine. Fine. This is fine either way. Device to host. Yep. Ready on GPU. Stored. Broadcasts. Ready on false. Atomic load explicit. If completed is greater than or equal to block size plus. Then they're ready on the CPU. All right. Brain is not braining right now. I'm trying to think what else I should just be checking other than just staring at this. So, I mean, we really only test the way simpler path with this no thread version. Oh, you know, what am I being? Am I being like this, right? I should just do here. Yeah, there's just dumb stuff that's not clicking with me right now, right? Like, why the hell am I not just doing this? M's? This, right? Okay. So this is the threaded version, right? This is our threaded version. About this. Good? Yes, good. Happy? Happy. Cool buffs. Ob's mismatch with 2 buffers. Instantly, pretty much, right? Yeah. Okay, so it's the buffered one that's screwed. It's interesting because we have, Interesting that that happens. But it's cool, though, that it, even the threaded version, it seems like it works and it matches with a bunch of threads. So it's just the buffering somehow. Let me think how that would be. I mean, it could just be something similar to what I had before, right? Let's go hunting for stupid shit that I could have broken. Buffers. Stream non-block. Okay. Hmm. Two buffers. We already tested this. Largest buff times blocks. Upside. Yeah. Fine. And yeah. True. Okay, hang on. Let me think if there's some interleaving bullshit here. Does it start processing? Processing as soon as actions are ready on GPU, right? Ready on GPU. Problem with that? Mm. Bothersome. I may like Tai Chi Lang. No. Bad Tai Chi. That's funny. Super funny. It's got to be something with this concurrency, right? The fact that wait, hang on. Let's just make sure I'm not being a dummy. Start and end. No, this is correct, right? I just want to make sure I'm not getting my test itself wrong. It's a really dumb way to be wasting time. Well, because that's not this channel, man. I think I stream enough stuff, you know? By the time I'm tired enough to boot up a game, I can promise you it's going to be even less interesting than watching me get stuck on a bug for 4 hours. I don't even think my brain has the energy to commentate stuff, Pepe, and I really want this thing to be done because, like, this thing is gating me from doing a whole bunch of other stuff, basically. And I don't think it's gonna get better for the next, like, week. I think it's pretty much just, like, finish this, and then pretty much everything else I have to do for the rest of the week is easier than this. Indie games? I'm currently been playing Evan Shore. It's like this single-player MMO by a single dev, and it's pretty awesome. I wonder if there anything we can get printed. It's all gonna be async, right? Main thread isn't. Does that help us? Help us. I mean, it's a combination of me, like, being tired, but also this is actually kind of genuinely hard. This is a non-trivial threading architecture. You've got the main thread, you've got a manager thread, and then you've got a whole bunch of these worker threads. And they're also, all of these are passing GPU buffers back and forth. So it's not very much code, but there's actually a fair bit going on here. Have I made any fundamental errors here? Wait. Hang on. Ob's ready. No, I don't think so. I'm not depending on the stream here, am I? Hang on, let me just make sure I'm not depending on the stream. Wait, ob's ready on CPU. Wait, ob's ready. Let me see what order I do this in. See, these copies here are synchronous. So these obs are ready on the CPU. They're also ready on the GPU. So like, this waits for everything to be done. This doesn't do anything, but it doesn't matter. Atomic load. These are bools, right? What about send? That. Threading. Actions are ready. Stream is synchronized. I'm gonna add the end index to this, or the block size. I'm gonna wake up the threads. I'm gonna call store. If this were syncing wrong, it would just hang. It wouldn't be wrong, it would just hang. And then you do atomic load on the completed index. Completed has to be greater than block size plus the start index. Block size. Verdict. There's some use for it, I believe, E10. We're gonna do another stream probably tomorrow on it. A lot of the stuff that I wasn't sure about, apparently it exists, it just wasn't documented, like where it was obvious. So I'm gonna go back through tomorrow. We'll have to see. Being developed by 3 people. Is it actually 3? Is it like 3 plus all the open source stuff? You need a GPU to contribute meaningfully to Pufferlib? No, not at all. Like, you can still develop environments and stuff. And actually, if you've built a couple environments that work well, you'll get access to GPUs from us anyways. GPU, that's funny. Well, I mean, if they end up making something better than Torch and Jax, like, how funny is that gonna be? I mean, Pufferlib is this, and, we are 100 to 1000x faster than everything else out there. Also being simpler and less code. And that's with me spending half the time being stuck on dumb stuff as well. Jax is 300 people? Yeah, and it's ass. Library is so bad. Use on my library when I make one, if it's good. Not easy to do that. You guys have a low price GPU to recommend? Not really. I mean, we use, like, our machines are, they're cheap by data center standards, but they're not cheap, right? We just have, like, high-end desktops. You can train even on CPU a lot of our simpler environments at, like, 100,000 steps per second, but on GPU we can get up to, like, 3 million, so. All the math stuff? No, it's just, like, making a good tensor library is not easy at all. You actually need to know what the hell you're doing. Oh yeah, also, I thank you for reminding me. So yeah, it's, if you want to, like, just train some stuff faster, yeah, like 30 cents an hour on Vast is pretty good. Cuz, like, you can pretty much do all your dev on CPU and even some of your smaller training bits. Wake up other threads without a safety lock. Get stuck forever. Cool. The LLM is fucking stupid because it does not hang. I would know exactly what to look for if it were hanging. And what's happening is we're getting different data. With 2 instances of this, we're getting different data. Well, I can't code. Then it botches things, not a no. Maybe another year. That's what they've been saying for 3 years. No more programmers in 6 months or a year, or whatever. And then every single new model that comes out, I try and it's shit. And everybody raves about how good it is. And then I try it and it's like, it's eating glue. I'm trying to think what other tests can we run? We should be able to come up with some stuff, right? Yeah. Try this. That's interesting, right? Two buffers. Okay. This is what we needed. I don't know why I didn't try this before. I'm tired, I guess. Let me just make sure it's not just rarer. Yeah, that looks good. So it only breaks with 2 threads. Or more. So it's gotta be then... I mean, the only place that uses the threads is right here. Most people just don't have actual meaningful engineering problems. Oh, they have meaningful engineering problems. They don't have meaningful engineering talent for the most part. Like, a lot of it's like, oh, well, these OpenAI researchers or these, like, Google guys use it or whatever. It's like, yeah. Have you seen scientists write code? Like, the ones who are good at it are very effective, but vast majority of, like, research scientists just have not put any meaningful effort into learning how to write good code. You can kind of tell as well when people are, like, really heavily relying on LLMs for everything that they talk about. Because, like, they mess up weird stuff, right? Like, it's like they have superficial knowledge, but they mess stuff up that, like, you know, you shouldn't be able to be this confident and knowledgeable about this thing without knowing about this thing, right? It's like stuff's out of order. There's some tells. Okay, so we know the bug is right here somewhere with how we're syncing this shit. Presumably here somewhere. This is everybody wake up. And then everybody grab some of this. X less than end. Get step of some M's. Ah. You dummy. I see it. Okay, I see it. Yeah, I see the error, guys. So it's, if you have 2 threads, this completed index is not correct because it can be adding stuff out of order. I see it. This is actually an architecture design oversight on my part. Let me go walk around for a couple minutes, and then I will consider how to patch this. Okay. Here's gonna be the deal, folks. It's 4 p.m. I'm tired. I've been banging my head against this all day, but I understand the problem. I'm going to explain this in a way that makes sense, even if you are not super experienced with concurrency and all this crap. Y'all can give input on how to fix it. We're gonna figure this out in the next hour. Then I'm getting dinner. I'm gonna get myself a nice glass of wine, and I'm going to bed super early. That is my plan for the rest of today. So, here's the problem. We have a bunch of environments, right? And these environments need to get updated, need to be stepped through. The way that we do this is we have a whole bunch of threads, and the threads are supposed to be able to grab environments as they come in and update them. So the problem is that right now, work has to be completed in blocks of, say, 2,000 environments. Okay? And the way that we do this is each thread is going to look at the current index, like what needs to be completed. It's going to safely, in a way that it's not fighting with the other threads, it's going to say, okay, I'm going to be responsible for this environment and the next 256 of them or whatever. Okay, and then when it finishes that, it says, cool, the total number of environments for which we've completed work goes up by 256. So the problem is what can happen right now is if you have multiple threads all checking out different blocks of work, you can have like thread 0 can check out 0 through 256 environments, and then thread 1 can check out 256 through 512, and so on and so forth. And let's say that you complete environment 1024, in that environment, in my example, let's say you complete up to environment 2048 before you've completed some of the previous ones. You can increment that index of completed past the earliest environment for which you haven't actually completed. So you actually want to track is what is the index of the earliest environment that hasn't been completed yet or whatever. So when you go and check, hey, are we done with this block of environments? You've counted the total number of environments completed, but you have it wrong because they're not the environments that actually need to be completed. They can happen out of order. Yeah, that's my plan for the evening, Pepe. This is a design flaw. Can't you just add a count? A count of what? +1 when an environment. Yeah, so but then they can count out of order. Because you can go like, they can grab work off the queue, and the ones working on the higher index environments can finish first. Track of processing buffers with a hash function. There's some difficulty because you're also limited in synchronization primitives. But pretty much all I'm using now is I have the ability to increment or decrement a counter by whatever value I like in a way that is safe, such that it's not going to have two threads trying to do it at the same time. What you really want to know, I guess, is the minimum index. Let me see if I can reduce this problem to something that's gotta be standard. Actually, this can be an LLM question. I'm sure this is basic, but I have to frame it in a simpler, like a standard format. Multi-threading problem. See. Suppose you have an array of elements, process, threads. No. Each thread process. Completion bitmap. This is shit. Oh, that's shit. Isn't this, like, literally wrong? I'm pretty sure this is literally wrong. Good job, state-of-the-art language model that everybody spent whatever amount of time on. That is shit. It's not a simpler solution, it's just wrong. I don't know if it helps. So you need the counter to be how many dones or which aren't returned. I don't know what we need. I just know the constraints. Atomic array. Yeah, okay, so this thing's fucking dumb. Let me think how we do this. We can lag it a little bit. How far ahead can it possibly get? Is there any limit? Yeah, there's literally no limit on how far ahead it can get, is there? Oh, that's such a pain. I mean, that's super annoying. Hang on. Let me see if I can get this problem into a canonical form. It is literally the thing that I just wrote. So counting up. Come on, that can't possibly be... You can't possibly be telling me this is the best way to do it, right? No way. See? Sleep. Worker, get next work. Yeah, this sucks. Because you still have to go through... Thread safe queue. I think it is it? How do you implement that, actually? You probably have to have, additional synchronization. What the fuck did it even write here? Oh. Yeah, this is not good. Okay, it just, like, this technically solves the problem I gave it, but, like, it hacked the test case, basically. Stupid thing. Okay, what do we do? What do we do with this? Working. Buffer. Each. Yeah, but then you have to split your work. Like, You have to split your work into a ton of chunks. And then you have to iterate over it. It's like very complicated. There's gotta be a better way to do this. How the fuck is there not? Okay, I have an idea. Let me frame this another way. Comic. Current min. Wait, what the fuck is this? Okay. Boarded set, that's ass. That's terrible. Absolutely trash. You have to loop over these? Damn it. Per buffer is not terrible, though. That's better than per block. Or per thread. So we'll just do... Here. You write a recursive function? How the fuck does that make any sense, dude? Mass index to worker thread. Annoying as fuck. You save time instead of looping through something. That's not remotely true. Yes, but you're completely misapplying that in a way that makes absolutely no sense. Like literally just try to write out the full idea of like how recursion makes any sense here, like what you would do step by step, and you'll see that it makes no sense. super obnoxious, isn't it? Oh, what's that? Is that from Tim? Ooh, Sokoban with Puffer? Yo, you on stream, Tim? It's Tim, right? Yo, that's actually a really good env to add. I don't know why I didn't think of that one. Look at Tower Climb for some examples. I think it'll be substantially easier for you because the map gen is not gigantic. But yeah, Sokoban could be a really good env. The maps. How many maps they have? Do they have a lot, or is it like not? They have a lot? Alright, if they have a lot, then they have a lot. There's an algo to make them hard medium, yeah. Yep. Game logic pretty easy, yeah. It's actually, the map gen is the only hard thing, right? Like, Sokoban, literally the map gen is the only hard thing. It has to be solvable and interesting. That's fine, Tim. This will be a good env. I'd probably do partially observable. Just because otherwise you're gonna tank SPS. So I'd probably basically do it like mazes where you get 11 by 11 window. 11 by 11 window, U into 8. Like, you only need like 3 or 4 channels. Actually, you only need... Wait, why do you have boxes and... Oh, holes. Wait, is the goal to put the boxes on the holes? Is that it? Ten by 10. Well, 10 by 10 doesn't make sense, right? 2, 3. Oh, the whole map. Okay. That's annoying that you have 4 things, because otherwise it would be easy to do 0, -1, and 1. But, okay, that's fine. That's fine. Not a problem, I'd say. Very good maximum puffing. Oh, this is a problem too, though. Fuck. Ah, that's a big problem, isn't it? Hard to think about. I'm gonna try some other. I'm gonna try this again. Wait, isn't this fine? I think it's fine, isn't it? Yeah, I think it's actually. Wait, I can salvage it. Comic that door. I think I can get this to work. Yeah. This is still wrong. God damn. Why is this so difficult? I think I actually... Do I know how to do this? Can I not just do... no, I'm not thinking clearly. Interesting. Spec threads. Really? Interesting. Uh, well, yep. That's annoying. Read this fresh. I'm gonna have to go in 10 minutes, folks. We'll see what I can do on this. But just so I mention it, it's all open source. Puffer AI, start of the Puffer helps me out. Discord for dev, X for more RL content, follow, etc., etc. Let me see if I can figure this out in the next 10 minutes. It's like close. It should be at least. Maybe. I think I just kind of need a break. 2 days. I'll take one soon, don't worry. on. What have I missed? Minimum index. Set this index. Crossing that meaning. Okay. Then, oh wait, X. This counts up to threads. Needed index. Plus I. Add. Currently grabbing that one. This one needs to be weird. Hmm. To all be above the block index. Add explicit. Weird. Ah, man, this is just weird. Is it always at 4096 now? Well, actually, it's always at the boundaries now. That's interesting, right? Hang on, this might just be an off by one. I thought I had it, man. Assembly level work? Not yet, Eric. And I thought I had it. That definitely made it more consistent. Greater than. Yeah, but shouldn't need. Not freaking ECC memory, man. This is very close. Jacks. How's that not? Could be another bug, to be fair. Be weird. Block size. Plus. Blocks matter, right? Matter. No, that should be fine. What the heck is wrong with it? None. Completed index is less than the. I don't know what's wrong. I'm gonna call it, guys. I'm too tired to do this now. I will be back tomorrow with Tiny Grad. Might have to finish this. We'll see.